So let's begin. So last couple of lectures we have taken a look at the introductory idea of object-oriented programming and the concept behind the .NET framework. So for example, in the last lecture we discussed that anytime you write C# program and you have to pass it through a compiler, right? So does it produce the machine code? Or no, it produces what we call the IL code. And the reason they do it is very similar to Java, just like Java produces a bytecode, so that we have a portable system, meaning so that our code can run on any operating system without having to recompile it, right? Okay. So then we also discussed, in order to run this IL code, how does it work? Do we load this IL code into the memory of the computer? No. Okay. In the memory of the computer, we load what is called CLR, Common Language Runtime, which has three main parts to it. For example, the just-in-time compiler. Okay, what's the job of the just-in-time compiler? To take this IL code and convert it to machine code. Okay, the second part of the CLR was garbage collector, and third was runtime safety and error checking environment, right? Okay, what's the equivalent of CLR in the Java world? JV. Okay, so that's why, as I mentioned, if you know Java, it's very easy to switch to .NET or C#. And if you know C#, you can learn Java within a day. So that's one of the nice things about learning both Java and C#. Both are very important languages, as we've already discussed. Okay. So now we also discussed that when we write programs, okay, we will create some classes of ourselves. Okay, so in the object-oriented world, every code that we write belongs to a class. Okay, for example, if you declared a variable like this, and it does not belong to a class, your code will not compile. Okay, so it has to be inside a class. Okay, whatever class name you give it, right? Okay, so we create some classes. We pick some of the classes from the .NET library. So these are pre-created for us. Okay, what we do is we reference the class from the .NET library. Okay, so the terminology that we use whenever we need to pick a class from the pre-created library, the terminology is called reference. Okay, so for example, if you are using Visual Studio, you created some class, for example, and now you wanted one more class from this library. So you will go to the project, you'll right-click on it, and you will say Add Reference. And then you will pick whatever library you are interested in. It will already be pre-compiled. So these are often referred to as DLLs. So you'll pick the DLL, and then you will automatically get the class that you need to use in your project. So gradually you will learn that, right? So anyway, we pick some classes from the .NET library, create some classes of ourselves, then we pass it through a compiler. And just like we discussed, this will create IL code, and then the CLR will read it, convert to the machine code, and then the CPU directly executes the machine code, right? So that's the execution environment under .NET, okay? We also discussed that in the last lecture, that the .NET framework, okay, which is basically an environment for creating applications, including the CLR, okay, including the library. So all this environment is referred to as the framework. Okay, so one of the nice things in the .NET framework is that, for example, when .NET was released in 2000 or around year 2000, the framework version was 1.0, right? So then a couple of years later, around 2001, 2002 time frame, they improved the framework. They called it Framework 1.1. With every framework, there's a separate CLR. So separate CLR with each framework. And every couple of years, they keep improving it, keep introducing new frameworks, okay? So for example, around 2004 time frame, it was framework version 2.0. Okay, so this is again the framework version. Okay, then around 2006-07 time frame, it was framework 3.5. 2008-09 time frame, framework 4.0. Anyway, the latest, which is 2015, is framework 4.6. Okay, so if you have to create anything new, you should use the latest framework. Okay, and once again, with every framework, there's a separate CLR. Okay, so one of the nice things about the .NET environment as compared to Java, even though they've now included it in Java, is that multiple CLRs can exist in the memory at the same time. So there could be a CLR for framework 2.0 as an example. There could be CLR for framework 4.6 as an example. There could be CLR for framework 3, so on. They can exist simultaneously. So for example, if you created some code over here, so you created some code, and some of the classes it's using are coming from this framework library. Okay. Now your code needs to call into some of the classes which were developed earlier, older version. Okay. You can easily do that without having to do anything special. It will automatically know which framework, and because they are residing in the memory at the same time, the versioning becomes automatic, okay? As opposed to Java, where only one JVM exists in the memory, so either you target JVM or JDK 1.4 or 1.5, okay? So that's one of the advantages. And because from the very beginning they designed it this way, so another benefit is every few years they keep improving the language, okay? So for example, over here, this was C# 1.0 as an example, right? Then C# 2.0 over here, okay? This one is C# 5.0 is the latest that we are using, okay? And with every improvement, every new framework, they keep adding more and more features to the C# language. So gradually I'll introduce those features, okay? So again, as compared to Java, where changes do not occur for another 5 years or so. Okay, here changes keep occurring, and they don't have to worry about backward compatibility because multiple frameworks can exist in the memory at the same time. Okay, so anyway, so that was the big picture. Another small comment was that, as I mentioned, there are over 100 different languages, programming languages, that we can program under the .NET, okay? And all these languages share the same library. So it doesn't matter whether you program in C# or you program in Python or you program in C++ or any other language, you are using the exact same library, okay? So then the question is, why should we learn C#? You know, if you already know C++, why not learn Python? If it doesn't matter what language we use, okay? And the answer is, as you will discover as I keep going, C#, because it keeps evolving every couple of years, it keeps adding new features. In my opinion, C# is the most, I should say, expressive or elegant, or however you wanna put it. So what that means is, in a very small amount of lines of code, you can create something which will take you, for example, 3 times or 5 times the amount of code. Okay, so it's not like you can do something in C# which you cannot do in Java. You can create anything in any programming languages, but how much time do you spend? That's where the difference comes in. C#, because being the newest, usually in a very short amount of time you'll be able to create some very sophisticated applications, right? Okay, so that's the reason we are picking C#. Python, by the way, also is becoming very, very good. Some of you are already taking the Python course. If not, later on, I highly recommend to take the Python course. Then at least you'll feel comfortable. You can program in anything you feel like it, right? So now coming to our learning of C#. First thing we need to do is learn the fundamental object-oriented programming. Then I will move to the intermediate level, and then I'll move to the advanced level. So even though we are going pretty slow, gradually I'll pick up the speed. So coming to basic object-oriented programming, as we discussed, we have 3 key concepts in the basic object-oriented programming. And what are those? Encapsulation, inheritance, and polymorphism. So today, let me try to finish the basic object-oriented programming so that we can start looking at more interesting things. Okay, so encapsulation was basically creating classes. Because remember, once we create a class, let's say some class XYZ, right? We create some variables in it. Okay, sometimes we call these fields, right? And then we also pretend this box is a function. So we also write functions inside a class which have some code in it, right? So which do something useful for us, okay? So as you can see, the class is essentially creating a virtual box, right? Okay, so then we also discussed that, and see, not only we want to learn just the object-oriented programming, we want to learn good object-oriented programming, right? So in good object-oriented programming, we have some guidelines. Okay, so one of the guidelines is when we declare the data or the variables inside the class, should we allow open access to those variables? No. So they should be private, so that from the outside nobody can modify it, right? So then how will we make it useful? As we discussed in the last couple of lectures, we provide tiny get function and set function. In C#, we use property to wrap the get and set inside it, okay? What about functions? Do we keep them private or do we keep them public? Okay, the functions I mean, most of the time we keep them public, even though you can make it private if you think it's only locally needed. Nobody from the outside needs to use it, right? Okay, so in the terminology, the functions are also called methods. Okay, so a method basically means a function belonging to a class, right? Okay, so that was the basic encapsulation mechanism. Declare some data inside a class, expose it through a public property, write some useful function. So just like we created the student class, right? Okay, so now there are some small concepts before we move on to the next part. So let me quickly go over those. Okay, first concept is, okay, let's take a look at our student class that we created last time. Okay, remember we had 5 fields in it, right? String, first name, by default it's private, correct? And then the corresponding public property, we had last name, we had ID, we had test1, we had test2, and we had one function, compute rate, right? And whatever the code is. So this returns the grade A minus, B plus, whatever the grade is, right? So the class starts over here, finishes over here, okay? So if we wanted to create one object of the class, so somewhere in our button handler, so if we created a button on the form, we will write some code like this. Student S1, new student, okay. So as we discussed last time, if we do not use the keyword new, then where does the memory come from? Stack area. So if this is the CPU, if this is the memory, so remember we discussed that there's a code area. So whatever code we are writing, this one, the button handler, it will be compiled, and once the CLR converts it to the machine code, it will go into this code area. So this is all the code that we have written. So now as we execute the program, somebody clicks on the button, we need to allocate memory for one student, which has 5 fields. So we need 5 pieces of memory to be allocated over here. So where will that come from? If we use the new keyword, where does it come from? Heap. The heap. So as we discuss, this is actually 2 different things. Student S1, basically, see there's no new keyword over here. So S1, we call it a reference. Reference is like a pointer. So this part will simply create this reference, right? Now we go and take a look at the second part, which is new student. So now the computer will go and check how many fields do we have. Whatever the private fields are, remember the public property is basically a function it's a wrapper for the get and set. So the public property will go into the code area. Only the memory for the private fields will be allocated, and because we said new student, it will allocate memory for first name, last name, ID, test1, and test2, right? And collectively, this is the data for a student. So now we said student S1 equal to new student, so this S1 will point over here, okay? So as soon as this line executes, this is what will be created in the computer. These will come from the heap area. This will come from the stack area. And the code for the class, the code for the button handler will be sitting over here in the code area, right? Okay, now what if we wanted to store some data? Remember there's a public, for each private field we have created public string, first name, right? And there's a get in it, there's a set in it. Okay, so once again, anytime we use the variable with the capital letter, that's basically a wrapper for a get function and a set function, okay? So now what if we wanted to initialize the first name, let's say to Adam? So what will we do? S1 dot first name equal to Adam. So now let's take a look, what will this do? Okay, first name is wrapper for get and set, and because this is appearing on the left hand side, that means the set will be called and Adam will be stored over here. So bottom line is the computer will start from S1, come to the first name, and Adam will be stored over here, right? Same way, what if we wanted to store the last name, let's say Anderson, so last name equal to Anderson. So we'll start from here, again, S1 dot last name, locate the last name, and it will store something over here as an example, right? So how many lines of code will we need to write to initialize all the fields of one student?
Right.
5 lines of code, because we have 5 fields, right? So generally, whenever we write code, we want to economize on the number of lines of code. The less lines of code we write, the more it's cheaper to develop the software, takes us less time, easier to upgrade, because we are looking at a small number of lines rather than a large set of lines, right? Okay, so we can reduce having to write 5 lines of code if we provide what we call a constructor inside the class, okay? So as most of you already know, constructor is a function, so it is a function. Okay, and its job is to initialize the data. Okay, so somewhere inside of our class, somewhere at the top or before we end the class, we can add now a constructor over here. So what does the constructor look like? Okay, so a constructor, very briefly, has same name as the class name. Okay, and does not return anything. So as you can see, this concept is same as Java, same as C++, so nothing new over here. Okay, with one small difference, which I'll point out in a second. So now let me pretend above the string first name line, okay, we write this code, public. And by the way, constructors, because it's a function, right? And functions, how do we declare them mostly? Public or private?
Public.
Public, right? So that's why it has the same name. The function name is the same name as the name of the class. Okay, so it will also be called student, right? And job of this function is to initialize all the fields. So what we will do is we'll give it 5 parameters. So we can say string, for example, FNM, string LNM. ID was an int, we can say ID. Int test1, sorry, all of these are comma separated. And int test2. Okay, so whoever calls this function will give us 5 pieces of information, and all we will do is take each one of those and store them in our own private fields. Okay, so what's our first private field called? First name. So the code over here will simply say first name equal to whatever we are receiving over here, for example, FNM. Okay. Same way, what was our next field? Last name equal to LNM. Okay. What was our third field? ID. So we will say ID equal to ID. Okay, so which ID we are talking about? The ID that we received as a parameter, or the ID that is part of the data inside the class?
So on the one on the left is the one that is from the variables, and the ID on the right is the local the ID
Right.
that is passed.
Right? Okay, so as you can see, still somebody may get confused, ID equal to ID, because one of these corresponds to this, one of these corresponds to the data inside the class, okay? So because there's a confusion, so often to clarify, we will say this dot ID equal to ID. So this is a keyword. Basically it means the object that we are dealing with. So in this case, because this is part of the student class, anytime we use the this keyword, that basically means we're referring to the data for our class. So this way there's no confusion. This dot ID will be the ID belonging to the class, and this ID will be the parameter over here. So this ID will be the parameter that we are receiving, okay? So anytime there's a confusion in names, to clarify it, we'll further use the keyword this. So let's go to the next one. Should I say over here, test1 equal to test1?
This just test one.
So again, the better way will be this dot test1, right? This dot test2 equal to test2. Okay, so anyway, this is what we call a constructor. And by the way, the comments in C# are exactly like C, C++, Java. You can use // so this is a comment, meaning this is just for our own clarification, okay? Or you can also use /* and then whatever and //. So this is a multi-line comment. Okay, so now let me point out one small difference between C# and C++ as an example. Okay, as soon as you write this public student, so this is a constructor which takes 5 inputs, right? 5 parameters, and then initialize all the data in one call. Okay, so once we write a constructor that has 5 parameters, right? Now if you go back to the program that you have written like this, where one by one you were initializing it yourself, you will notice this program will not compile, okay? So we'll start to give you an error on this line, okay? Why does it give us an error on this line? Even though previously was working correctly, it's because we provided a constructor and it takes 5 parameters. So now it's expecting 5 things over here for us to pass. Okay, if we don't pass 5 things, we leave it blank, it gives us an error. Okay, so so let me point out one of the concepts in C#. So in C#, if you provide a constructor with parameters, okay, then C# removes the default parameterless constructor. So let me clarify this part, but this is what you should remember about C#, which is unlike C++. Okay. Okay, so pretend we did not write this, no constructor. Okay, so this is not there, and this is working properly. Okay. The reason it works properly is, see, anytime we write parentheses, what does that mean? See, if I say int a equal to 5, int b equal to a, right? What I'm doing over here, I'm simply assigning one variable to another, right? But what if I say, let's say double result equal to compute ABG, let's say 579. Pretend we have something called compute ABG. So what does this mean? What are we doing over here in this compute ABG? We are calling a function, right? Okay, so remember, anytime, so what if the function does not do anything? So for example, we wanted to do, let's say, update record in the database, okay? Or delete record, right? So So these parentheses, anytime we put these parentheses, what does that mean? We are calling a function,
Functions.
right? So same way, take a look at this line, student S1 equal to new student, okay? Do you see over here? We always write it like this, or with some parameters over here. So what does this mean?
You call
We
it
are calling
constructor.
some function. Which function are we calling?
Constructor.
The constructor, because the constructor has the same name as the class name, right? So this part always calls the constructor. Okay, so now let's come to this part. Suppose we did not write this, no constructor was written, okay? This one still succeeds. How come it succeeds then?
It creates a default constructor.
Because C# by default inside the class will have a constructor which will look something like this. Public student, begin curly, end curly. So this is called the default constructor. So this is automatically there even though we don't see it, okay? As soon as we create a class, so if we do not write a constructor, this is already there. So previously, why did it work? What did it call? This one called this
Default
one,
constructor.
right? Even though it does nothing, but it's there and that's why it succeeded. That's why we had to initialize it one at a time. Okay, the minute we add our own constructor, what does C# do? It removes the default constructor, okay? So because it's no longer there, only constructor there is with 5 parameters, this one will fail. This will give us an error message, okay? So we have 2 choices. A, do not use the default constructor. We now pass some data, for example, Bill Baker, 1, 2, 3, 4, 5, 85, 91. Okay, so Bill will become the FNM over here. Baker will become LNM. ID will become 1, 2, 3, 4. Test 1, 85. Test 2, 89. Okay, so we always create a student by passing some data to it. So that would be one option. Okay. But what if sometimes we wanted to create a blank student, okay? We wanted to populate it later, not at the same time, okay? Then what's our other option? Other option for us is to type this ourselves. So you'll just type the constructor with nothing in it. So you will provide the default constructor explicitly, as well as the constructor that takes 5 parameters, okay? So in short, okay, as a general guideline, okay, what you should do is you should always write 2 constructors. So provide 2 constructors in a class. Okay, one will be the default or parameterless constructor. Okay, what will be the second?
Parameterized.
With as many parameters as what? As the number of fields. So if you have 5 fields, you will provide a constructor with 5 fields. If your class requires 7 fields, you will provide a constructor with 7 fields, right? So both of these will be somewhere in the beginning of the class, okay? And like I said, order doesn't matter. Even if you wanted to put these constructors before you end the class, that's fine also. Everybody has a certain style. When I program, I usually write the constructors at the top of the class so that I can see how the initialization is going, right? Okay, so once we have written two constructors, one like this, right? Remember both of them are functions, right? And in both cases, what's the name of the function? Name of the function is
Stream is the
student,
class.
right? So anytime we have two functions with the same name, so if inside our class we have two functions or two or more functions with same name, okay, this concept is called overloading a function. Okay, so let's pretend we create a class. One of the functions was something like this: public double compute ABG int A, int B, int C, return A plus B plus C divided by 3.0. Okay, suppose inside the same class, I also write one more function, and this is called compute ABG, and this has four parameters: int A, int B, int C, int D, okay, and it does return A plus B plus C plus D divided by 4.0. Okay, so both of them are inside some class called, let's say, XYZ. Okay, so first of all, is it okay to have two functions with the exact same name?
Yeah.
Okay, and the answer is yes. Okay, and that's one of the concepts in object-oriented programming, and that concept is called overloading. So we can overload functions. Okay, so this is perfectly okay. And once again, what does overload means? Two functions
with the same name.
with the same name. Okay, so for example, compute ABG, both of them are called compute ABG, both of them are in the same class, okay? One of them takes 3 parameters, one of them takes 4 parameters, so it's perfectly okay. So in the object-oriented terminology, we will say over here that compute ABG is overloaded. Okay, meaning there's one more compute ABG inside the same class. Okay.
If both functions have same parameters, so
Correct.
can we write in same class?
Okay, so now there's a certain restriction in overloading. Okay, so we cannot just keep writing many functions with the same name. So the rule in overloading is, okay, as long as either number of parameters or type of parameters is different. Okay, then you can overload it as many times as you feel like it. Okay, so that's the rule in overloading. So for example, let's take a look at this example. How many parameters do we have over here? 1, 2, 3. How many parameters do we have over here? 4. So that's okay to overload. Now what if somebody came over here and said, no, we want to take the average of not 4 integers, but we want to take the average of 3 integers. So they changed it to double X, or let me just leave it. It doesn't matter what name we give it. Double Y, double, or double B. and double C, okay? So now is it legal to have both of them be called compute ABG?
No.
Both of them are taking 3 parameters.
Yes, because the type is different.
Because the type is different, right? So take a look, either the number or type is different, so you can overload, okay? What if I did this? In this case, I changed the return to int instead of a double, meaning once it returns the integer, we will convert, so even if the data was 3.7, we'll convert it to 3 or 4 and just return it as an integer.
Yeah, you can.
So, is this legal?
Yes.
Yes or no?
It is legal.
Yes.
It
Okay,
is
the
legal.
answer is no. Okay, why? Because the, sorry. Because the parameters are different, it will be legal.
Yeah.
But let me change this to now int.
Yeah, now it's legal.
Okay, so this is returning an int, this is returning a double. So is it legal or not legal?
Not
Can
Not
we
legal.
overload it or we cannot overload it this way?
we can't.
We
And
can't.
the answer is, again, if you take a look at the rule I gave you, it only talks about the parameters, it does not
Not
talk
the
about the return, okay? So the parameters, if there are 3 integers, even if you call them over here, let's say x, y, z. If you call them x, y, z, then in your code, you will be writing x plus y plus z, right? So even if you name them differently, can we overload them now?
No.
No, still not, because it strictly goes by the type. And what is the type over here?
Int.
In 3 parameters, all of them ints. So they are the same data type, same number, so this is not correct, okay? So once again, either the number of parameters have to be different or the type has to be different, then you can overload it as many times, right? So now let's come to our constructor example. See, constructor is also like a function. How many parameters did we have over here? 5. In this constructor, how many parameters did we have?
0.
0. Okay, so is the number of parameters different?
Yes.
Yes, so we can overload the constructor, okay? So anyway, once again, anytime you create a class from now on, I will expect you to provide 2 constructors, one with no parameters, okay, 0 parameters, one with as many parameters as the number of fields in the class, okay? Now, let me give you a few more concepts. Okay, and also remember this part that I talked about. As soon as you provide a constructor with parameters, as soon as you write this, what will C# do? Remove this automatic constructor that it gives to us. So you have to now type it. Otherwise, if you try to create a student with blank parameters, it will give you an error message, okay? If you have both of them, then it will be okay. So everybody is comfortable with constructors? And what's the job of a constructor? To initialize the data, okay? So now if we have these 2 constructors, right? What if we wanted to create 2 students with different data? So in our button handler, what will our code look like? It will look something like this. Student equal to new student. And in one line of code, we can give it some name. Let me just put Bill Baker 1, 2, 3, 4, 5, 85, 91, right? So automatically the student will be created. So once again, think of it, what will happen in the memory of the computer. Okay, in the stack area, S1 will be created, correct? So that's the S1. Okay, New student, as soon as the computer sees new student, what will it do?
Go to heap reference.
Go to the heap area and create the memory for the fields of the student. How many fields do we have?
5.
5. So we'll create 5 fields and connect this reference. So this is what we call a reference or a pointer. In in C++, the terminology is to call it a pointer. In Java, C#, we call it a reference. So now we'll point to the 5 fields over here. Because this data is being passed to the constructor, and the code in the constructor takes the FNM, stores it in first name, takes the LNM, stores it in last name. So you see this will automatically end up putting all the data over here. 1, 2, 3, 4, 5, 85, and 91, right? What if we wanted to create 2 objects? You will do student, S2 equal to new student, and for example, Sally, and so on. So what will it look like in the memory of the computer? Now there are 2 students over here. Okay, so this one is S2, and this S2 will be pointing over here, and it will contain Sally and the rest of the data. Okay. So as you can see, to initialize one student, how many lines of code we have to write now?
1.
1, whereas previously we had to write 5
5
lines of code. So the constructors make our life easy, right? Okay, so next concept is, okay, there are a couple of keywords that we use both in C#, sometimes in C++, but also in Java. And those keywords are associated with a class and the methods inside a class. Okay, the keywords go something like this. There's a static keyword. There's a override keyword. There is a virtual keyword. Okay, and there's an abstract keyword. So, static, override, virtual, abstract. So next thing we need to understand is what's the meaning of these keywords. So I'll give you small examples to clarify the meaning of these. Okay. So let's come to the static keyword first. Okay. Now suppose you created a class. Let's say my compute. And inside this, you wrote 2 functions, okay? You declared, for example, double. So first let me do this. First let me say public double compute area. Okay, and then double radius. So let's pretend the code over here computes the area of a circle. Okay, remember, anybody remembers formula for area of a circle?
3
Pi r squared, right? So this will do return, so let me just say double pi equal to 3.1415, return pi times radius times radius. Correct? So let's pretend we wrote one simple class with one simple function in it. If anybody calls this, it will return the area of the circle for a given radius. Okay? So now let's go and create a button in our form. Once we double click on the button, it will take us to a button handler. Okay, so if we wanted to call this function, let's say, and have it compute area of a circle whose radius is 5, okay, as an example, what will our calling code look like? Okay, remember this function exists inside a class.
So
C
object.
#, like Java, is completely object oriented. You cannot write a function without a class. Okay, everything belongs to a class. Okay, so obviously first we have to create an object of this class. Okay, so what will our code look like? My compute
And
MC equal to new my compute. So let me ask you again. What's going on once we say new my compute over here?
the constructor, the default constructor is called.
Default constructor will be called because we never wrote any constructor, right? And that default constructor doesn't do anything, okay? So anyway, once the MC is created, now we will do something like this.
MC.computer area file.
Double radius equal to MC dot compute area. And let's say 5 pointer. Right? So now at this point in time, what will the computer do? This 5 will become the radius, correct? It will start executing this code, 3.14.